Hi all, I'm Divya Somakumar and in this video we are going to learn about bias variance trade-off. Now, before delving deep into this bias variance trade-off, we will have to understand two concepts. We have to understand what exactly is bias and we have to understand what exactly is variance. Only then we can understand the trade-off between the two. Both are types of error. Now let's understand what is bias. Bias is the difference between the actual values and predicted values. Now consider the following graph over here. Here the predicted value is your red line and the actual values are your blue dots. Now what exactly is bias? Bias is nothing but the difference between the actual values, that is your blue points, and the predicted values which lie on your red line. A model with high bias pays very little attention to the training data and oversimplifies the model. It always leads to high error on training and test data. High bias can be reduced using regularization. Now, let's understand what is variance. Variance tells us about how scattered the data points are with respect to each other. So basically, variance tells us the distance between these different blue points. A model with high variance pays a lot of attention to training data and doesn't generalize well on the data it hasn't seen before. Now, let's understand the bias variance trade-off. Now, to understand bias variance trade-off, we have model complexity on the x-axis and we have the error on the y-axis. We have a downward sloping bias curve. What does that imply? When the model complexity increases, your bias starts falling. And we have an upward sloping variance curve. What does that imply? When your model complexity increases, your variance starts increasing. Now, if our model is too simple, that is if our model is somewhere over here and it has very few parameters, then it may have high bias but a low variance. On the other hand, if our model has large number of parameters, that is it is located somewhere over here, then it is going to have a high variance and a very low bias. So we are looking forward to a model in which we have low bias and low variance. That is the point where we have the best fit. So in case of high bias and high variance, we have underfitting model, and when we have low bias and high variance, we have an overfitting model. Our motto is to find the best fit model which has low bias and low variance. I hope everyone has understood the bias variance trade-off. Thank you.